Hi and welcome. If you don't know me, my name is Patrick and I'm with Build Your CNC and newbiehack.com. In this video, I'm going to show you how to set up the software environment, the IDE, which is the Integrated Development Environment. This is where you're going to write the programs that's going to be put into the microcontroller to make the microcontroller do something. The IDE also allows you to transfer the program to the microcontroller. I'm also going to add two other programs to this arsenal of programs, and those are the STM Studio and the STM32 CubeMonitor. Both of those programs will allow you to monitor what's going on inside the microcontroller in real time. So you can see what's going on, look at your variables, and in the STM32 CubeMonitor, you can also control, you can actually make changes to things in the microcontroller. In the last video, we talked about the hardware side of things and what you need to be able to successfully complete the projects in this tutorial series. But I want you to take a look and appreciate the simplicity in this setup versus an Arduino setup. With this setup, you'll have the intimate knowledge of all of the components that you're going to be putting into the circuit that you'll need for the successful project completion or a product that you wish to develop yourself. You'll see that what we have here is extremely simple. It's just a chip, the microcontroller, and it's broken out into these pins that is inserted in these three breadboards. The microcontroller is connected to the computer by this STM-Link V2 device, which is what I call a programmer. The device provides 3.3 volts of power for the microcontroller to run. It also has a 5 volt power if you need it. And it has two data lines. One is a clock and one is an I/O. These two work together to communicate between the computer and the microcontroller. The power pins of the microcontroller need to be connected to multiple pins on the microcontroller. These two pins here, these two pins over here, and this one pin over here. It can also be connected to a couple pins over here that's used for the analog to digital converter, but you only need to use them when you're using that converter. To be able to power the pins that are around the microcontroller, you need to connect the breadboards all together on the power rails. There are two power rails, one for the plus and one for the minus. And then those pins are connected to those power rails. Pin number 64 is a positive pin, and you'll want the 3.3 volt positive pin from the STM-Link V2 to be plugged into that pin. The ground pin will be connected to pin number 63. Pin number 63 will go to the negative rail. The positive and negative rail will be connected to this next breadboard. Negative rail to negative and positive to positive. Pin number 31 will connect to the negative rail, and pin number 32 will be connected to the positive rail. You'll also want to use a 0.1 UF capacitor between pins number 31 and 32, pins number 63 and 64, and pin number 1 is a positive pin, so it needs to be connected to the positive rail. And you'll have a 0.1 UF capacitor between the positive and negative on this rail, so it's as close to this pin as possible. And these two breadboards need to be connected for power as well, so positive goes to positive and negative goes to negative. So when 3.3 volts and ground is connected to these two pins, it will power the rails along the entire length of the power rails on all of the breadboards. The SWCLK, which is the clock, will be connected to this pin here, which is number 49, and number 46 is SWDIO, which is the I/O pin. You can see those two pins here, SWCLK and SWDIO. And this diagram here corresponds to the pins in the back of the ST-Link. The IDE I'm installing is called the STM32 Cube IDE. The IDE is based on the Eclipse IDE and modified to work with the CubeMX by STMicro. Search for STM32 CubeIDE and click on the link from st.com. On that page, scroll down below the description and a list of available downloads will be shown. I'm installing the Windows version. You will need to accept the license agreement and either log in or provide your name and email to continue with the download. The download will be in the form of a compressed zip file. Go to the file location and double-click the zip file to open it. I'm going to run the setup application directly from the zip file. The setup wizard will start. I am maintaining all default values for my installation, including the drivers for the ST-Link and J-Link. Now I will add the STM Studio and the STM32 CubeMonitor. Both of these programs will allow you to monitor what's going on with the microcontroller. With the STM Studio, it's very simple. You can monitor variables and you can show the variables in some state like a chart, a line chart, a table form, and a bar chart. With the STM32 CubeMonitor, you can not only look at variables, but you can also change and control the microcontroller while it's running in real time. So you have much more flexibility with the STM32 CubeMonitor than you do with the Studio, but sometimes just going to the Studio and checking a variable really quickly makes a little bit more sense, depending on the scenario. I will install STM Studio first. Search for STM Studio and click on the link from st.com. STM Studio gives you the ability to read and display variables in real time while the microcontroller is running. Just like the previous download location, the download is below the description of the program on the web page. Click the Get Latest link to start the download. You may need to either log in or provide some information, including accepting the license agreement. Open the compressed zip file that was downloaded. Like the previous installation, I am double-clicking directly from the application in the zip file. STM Studio requires the installation of the GRE, Java Runtime Environment. The program links to the Java Development Kit, but I have found that this does not work. To correct for this problem, you'll need to search for the Java Runtime Environment and install that program instead. You can see here that I installed the Java Development Kit, which is where the installation links to when I click the Yes button. And when I restart the installation of the STM Studio, it repeats the instructions to install the Java Runtime Environment. So here are the instructions on how to install the Java Runtime Environment instead. Search for the Java Runtime Environment on the internet. Click on the link under java.com, Java Downloads for all operating systems. You will be taken to a rather technical and non-adorned page with the download links. I am using the Windows Online link to install the Java Runtime Environment. Once the download is completed, click on the download and follow the installation instructions. Once the Java Runtime Environment is installed, STM Studio should have no problem installing completely. I am restarting the STM Studio installation. I'm also keeping the default values throughout the installation process. The installation creates a desktop shortcut. My shortcut is hidden in the sea of icons on my desktop, so I wasn't able to find it very quickly. So I used the Windows Start button to start the application. This is what STM Studio looks like. It is a relatively simple application. You specify the file associated with the program that is on the microcontroller, specify the variables, and view the variables in your choice of a bar graph, line chart, or table view. Now let's install another type of monitor called the STM32 CubeMonitor. Like the STM32 CubeIDE is based on the Eclipse IDE platform, the STM32 CubeMonitor is based on the Node-RED platform. The STM32 CubeMonitor allows you to view variables, but the application also allows you far more control over the microcontroller. You can create your own dashboard to control various aspects of the microcontroller while it's running. I will install the Windows option. Follow the same process as with the other applications. It looks like I downloaded the application twice. I think it is letting you download without logging in or providing the name and email information. After the download is completed, you will need to extract the files, so the installation process uses uncompressed files. I just created a temporary folder on my desktop and extracted, or clicked and dragged, the files into this new folder. From that folder, I can double-click the setup application. As with the other installations, I'm keeping the default values. When the installation finishes, it will launch the program automatically. If you are running this under Windows, some of the features of the STM monitor will need access through the firewall. If you are okay with this, click on the Allow Access for either public or private networks. This is what the program looks like when it starts up. I'm going to give you a quick tour of the STM32 Cube IDE. You can start the IDE by clicking on the icon labeled IDE. If you have a special place where you want to hold your files and your projects, change the workspace location. I'm keeping it as the default. This message will only appear if you have a previous installation of the STM32 Cube IDE. If you have another instance of the IDE, go ahead and click yes if you want to associate your project files. When you first open the IDE, you'll be presented the Information Center. In most cases, you won't be using the screen, but let's go ahead and click on the Start STM32 project from here. You'll need to select the chip that you're going to be working with. There are so many selections that you will need to use a filter to reduce the number of selections so you can find the chip. The one I'm using is at the top, so it's pretty easy to find, but you can filter using the ARM core type, the series of the chip, like F0, F1, L1, the ST micro product line, the package of the chip, like how many pins that the chip has and the size of the chip. For instance, we are using the LQFP64. The filter labeled Other allows you to filter by specific attributes of the chip. And finally, you can filter by the feature or peripherals that the chip contains. Say, for instance, you wanted the chip to have USB functionality. This is where you would go to find the chip that you need. Now that I know where my chip is, I can go ahead and click on it and press Next. The IDE will start the project creation wizard. You'll need to put in a project name. I'm naming this project Test Studio and Monitor since that's what I'm going to be doing. The target language will be C. I want this to be an executable, not a static library, and it'll use the STM32 Cube rather than an empty type. Click on Next, and on this page, you can leave everything as default. The code generator options might be something you will change in the future, but in this case, I'm leaving it default. Once you click the Finish button, the project will be created, but it'll also ask you if you want to open the perspective view, and I always click yes for this. This is the screen you'll be presented when the project is created. This is the .ioc file that is shown that has the microcontroller and the pins in an interactive graphical representation. If you want the initialization code to be auto-generated, this is where you do it. The initialization code is generally just setting up pins and timers and other features of the chip. In the Project Explorer, I'm going to open up the source folder and double-click on main.c. This is the main entry point of the program and where you'll do most of your programming. The IDE puts a lot of comment lines in the main. The IDE adds a lot of comment lines, so I'm going to remove those. Since in these tutorials, I'm going to show you where much of the coding will need to happen. The removal of these comments isn't absolutely necessary. I am removing anything with a /*, message, asterisk, and a /. So if you want to do this, go ahead and just remove any of those types of lines that you see. The purpose of this program is only to introduce a variable so I can monitor that using the STM Studio or the STM32CubeMonitor. Let's add a variable called test seconds. This variable will need to be a volatile variable. The volatile keyword is added just so the compiler doesn't optimize this variable out. And I'm initializing it as 0 so the compiler can infer that this is an integer. The test seconds variable will be updated in the while loop, which is the never-ending loop. But I don't want it to be updating that quickly, so I'm using a delay that is available from the HAL library. You may have noticed the list that appeared below the HAL delay while I was typing. I used the control spacebar to get that list, so it'll be a little easier for you to find the functions and variables available to you. This delay is in milliseconds, so I'm using 1000 milliseconds to equal 1 second, and I'm going to increment test seconds by 1 for each iteration of the while loop. Now we are ready to run the project, which is transferring the program to this microcontroller and monitoring the variable we just created. To do this, we need to plug the computer to the programmer, and you'll hear the notification on the computer that something has been plugged in. If this is the first time you're plugging it in, it'll take a little time to install, so just follow the prompts you have with Windows to make sure it's installed correctly. When you are running the program or transferring the program, or some kind of communication is happening with the ST-Link and the computer, there will be a red and blue LED that blinks back and forth. And there is also an error condition. I think the error condition is both blue and red are on at the same time. So let's go ahead and transfer the program to the microcontroller. Use the play button to initiate the transfer of the program and execute the program on the microcontroller. When you do this for the first time, the run configurations will appear. You can also see the run configurations dialog if you press the down arrow next to the play button and select Run Configurations. In this configuration dialog box, click on the Debugger tab. You want to make sure that under the interface section, SWD is selected. The ST-Link serial number does not need to be populated. If you want it to, just press the scan button. I set the reset behavior to none. You may need to set it as under reset. If you are having problems connecting to the target in this case is the microcontroller, then make sure that the connections to the microcontroller are correct and that they're solid. You'll have messages like cannot erase memory or cannot connect to target. Those are all signs of a bad connection from the microcontroller to the ST-Link V2 Programmer. After pressing the Run button from the dialog box or pressing the Play button, all of the information that gives you the status of the ST-Link and errors in your program will be in the Console tab on the bottom of the IDE. You can see here that I received a target comms error, and that's because I didn't have the USB cable plugged into the ST-Link Programmer. In this case, it said error, failed to erase memory. This was because my SWDIO was not connected securely to pin number 46. Sometimes you'll get an error that has to do with the GDB server. This is due to having multiple errors happen when trying to connect to the target. What you need to do is unplug the ST-Link and plug it back in, and then do the run again. I created these errors intentionally so you can understand what action to take. This is what the console will look like once you've successfully programmed the microcontroller. The status will have file downloaded complete, verifying, and download verified successfully, shutting down and exit. Now let's start STM Studio so we can monitor the variable that we have in the microcontroller. Make sure the ST-Link Programmer is still plugged in. We'll use the top pane of the display variable setting. Click the right mouse button and click on Import. We will need to locate the ELF file for the project that we just created. An easy way to do this is to go into the binaries folder of the project that we have in the IDE. Right-click on the ELF file under the binaries and click on Properties. Under Properties, you'll see the location. Just select the entire location, including the ELF file, and copy to the clipboard. You can cancel that to get out of that and go back into the STM Studio. The ELF file contains all of the information about the program, including information about the variables. In the STM Studio Import Variables from Executable dialog box, click on the ellipsis button and paste the clipboard into the file location text box. Don't worry about the unknown symbols error message that pops up if you get one. A list of variables will be shown in this dialog box, and you'll select the test seconds variable, Clicking the import button will add it to the STM Studio. We want to send this variable information to the var viewer1, which is the chart to the right. Press the play button at the top to start monitoring the variable. You can see that the test seconds count got up to 100, or around 100. That's how many seconds it took me to import the variable into the STM Studio. You can zoom in and out of this chart using the mouse wheel. In the display section of the STM Studio, you can select how you want to see the variable, as a chart, a bar graph, or as a table. What would happen if we went back to the program and removed the HAL delay of 1 second? Since this number can get quite large, I made it an integer data type. I'm going to rerun the program, make sure that the ST-Link was able to transfer the program successfully, and go back to the STM Studio and play again. In this case, I had to zoom out quite a bit using the mouse wheel, and you can see how fast the variable is climbing. Now let's try the same thing in the STM32CubeMonitor. Start the STM32CubeMonitor by double-clicking on the icon labeled MON. You'll need to allow access as before, and you'll be presented with the node-red flow diagram. This is the request, and this is the response. The probe is the ST-Link, so we need to create that or add that. Click on one of the probe nodes and click on the pencil icon on the probe config line. Click the drop down in the probe name to select the ST-Link. We're going to go ahead and add, and done. You can see that the little triangle, the red triangle, has disappeared. So we're going to go ahead and do the same thing with this. We're going to select the same probe, add, and done. Okay, so those are good. What this is doing is it's creating a dashboard. These are buttons. You can see by this little finger icon. This is where we're going to create the variables. We have our test seconds as a variable, so we can use that. And then it's going to send that to the probe or the ST-Link. And from the ST-Link, once it's past its request, it's going to create a response. So this is, some people call this a transmit and a receive. So on the receiving side, or the response side, from the probe, it's going to go back into my variables, which we have to create, and it's going to go to the chart. And we can also use, this is another button, we can clear the graph. All right, so let's go ahead and put the variables in there. So we have to put in our executable. Let's try that first. So let's go ahead and get the executable, the binary. I'm going to go to the properties and select this path here. I'm going to use Control-C to copy it and Control-V to paste it. Let's see, actually, let's put the folder portion of it in the folder area. All right, and then we're gonna, there we go. Oh, this is a name. Okay, we can name this something else. Just call it the Test Studio and Monitor. Let's go ahead and click on the test seconds, and let's add it, and we're done. So this should be connected with this. So if I double click this, it should be the same. Just go ahead and done. Click on the deploy button to accept the changes and click on dashboard. You can see that our variable is climbing very quickly as expected. If you've gotten this far and you are still with me, congratulations. You are ready to start your journey in ARM microcontroller development. Thank you for watching.